Hello everyone, and here we are again back after 2 weeks of break with another episode of ITS Laboratory Speak Up vlog. And today our guest is Biswadeep Ghosh. Biswadeep is a fire and life safety manager in WSP Opus, and he leads the team of fire engineers, being responsible that each and every project sourced appropriately and all the high expectations of the clients are met. So his expertise includes the fire engineering design in accordance with acceptable solutions and performance-based design of New Zealand. He actually maintains a good relationship with the regulatory authorities and his peers in the industry. Deep holds a bachelor degree in engineering electrical from Indian University, Delhi University in India, and he also got the master degree in engineering for fire from Canterbury University here in New Zealand. Deep, thank you for joining us today.
Thank you very much for having me on this program.
Perfect, thank you. So Deep, our episode today will be around remediation projects in the existing building. So if this is something you guys are working on in WSP Opus, and if yes, what kind of challenges are you guys facing while working on such projects?
Yeah, I guess a lot of work that we get in, not just us, but most fire engineers will be involved in is going to be existing building remediation work. So, not everyone's building new buildings. People are actually modifying existing buildings for either they're changing the occupancy type or they are actually just fitting it out with something different. Things like a lot of office buildings are being changed into residential tenancies at the moment. So that's the hot market at the moment. So less office space is required. So people are converting them into apartments. So that's like they're upgrading systems in there to make it suitable for being used as an apartment, or there would be offices that are being remodeled or repurposed because of with COVID, a lot of people have realized that there's less office space requirements, so people are remodeling it to make it more efficient and more user friendly with the staff who might be working from home on a part-time basis. So yeah, there is a lot of work that happens where fire engineers are getting into existing buildings to understand what the challenges are there. It could be non-compliances with the current code. There could be non-compliance from the previous code when it was done. It could be stuff that's happened over the time where things have just not been maintained or things have not been done correctly. So yeah, things like that. So yeah, it is one of the bigger challenging things for fire engineers, I guess, and the same for my team and myself, that when you get into an existing building, we find a lot of good things to see and sometimes not so good things to see. So yeah.
Right. Listen, I've heard that the expectations specifically to the compliance with fire regulations are getting harder and tougher with each and every year, specifically recently. If this is something you can observe and you can confirm from your side and acknowledge.
It's not getting harder or tougher. It's just that there is more scrutiny of how it's done and how people are actually demonstrating compliance with the building code. Most of the stuff was always there in the building code. It's just that because of the recent events around the world and things even in New Zealand, which we have looked at, which starts as a bit of a facade replacement project, it becomes a different project completely. There's a big challenges in fire and stuff. So I guess there's more scrutiny on what's being done. The industry is learning from the past mistakes, and I guess we are moving forward to a more safer and more robust building stock.
Right.
I guess that's where it's going to be.
It's very clear now, but clients, they are inclined to complain, because that regulation that they imply that they would pay more for this, compliance, for the test, assessments, for engineering judgments.
Yeah, I guess it's more there's the need for us to be demonstrating more holistically that what's being proposed is actually going to work, and it's not just being there just for the sake of someone putting something in there. So therefore, it's not just for the regulatory authorities; it's also for the engineers to make sure that what they are proposing for in a building, especially in existing buildings where it's difficult to put new products or tested solutions, that they're actually being done in conjunction with what would constitute a positive test, I guess.
Right.
So,
Deep, I specifically asked you to watch the previous episode of our blog,
yep.
where our client, Shane White, was elaborating on his new system, paint system,
Yep.
Which he is applying in the remediation project of Christchurch Hospital. So from your perspective of the fire engineer, so what can be potential pros and cons for this system specifically?
So I haven't personally come across the system because we haven't used it ourselves from others. Although I'm actually catching up with Shane in a couple of weeks to understand what this system is all about. I think if it's a system that, what as he describes it to be, that you're going to use it on existing surfaces and existing try to make existing systems better than what they are, then obviously there is a great benefit where you're not actually demolishing and then rebuilding. However, the other aspect of it, which is not very clear, is the durability of these things. How long are they going to last? What kind of additional protection is required? For example, if you're spraying something on an existing wall to increase its fire rating, how good it is going to be when there's day-to-day damage on the wall, and what kind of remedial works are required. Large organization which may have an engineering team that does all the maintenance work, they might be able to do it, but what about that odd building that just gets developed with this solution? And how is it going to be managed in terms of the building warrant of fitness? How it's going to be checked? So there's a lot of questions that needs to be, I guess, understood. And I'm assuming it's being used, so they would have demonstrated that those things can be done with the regulatory authorities, and that's one of the things which I need to understand from Shane much more. That I mean, WSP has also got our building warrant of fitness team, so we as a company are very quite interested to understand how these can be used on site, not just when a fire engine comes along, but when our IQPs go and actually inspect buildings to ensure that they continue to remain compliant, and when they find some challenging issues or they find some defects, then how they can fix it. So these could be things which might help the industry going forward and kind of keep our building stock safer.
Yeah, and maybe you guys, as a WSP Opus team, will use Shane's solution as well on your remediation project.
Well, we could. I mean, we are open to solutions that might be available in the market, and innovation is what WSP strives for. So we will work with partners in the industry to get that innovation. If it one saves time and money for the client, that's the first thing. Second, I guess one of the key things that was talked in the video was about sustainability. So we kind of reduce waste management and try and reuse products that can be there, that can continue to enhance the life of the building. So from 50 years to 100 years and further on. So yeah, it's all good stuff. It's just how we try to actually use it and demonstrate the compliance with the building code and actually demonstrate that it can actually serve the purpose that it's being used for. It's not just a tick box exercise to satisfy a building consent authority. It's more of actually understanding that the system that's been proposed will actually work in the long term,
Right.
without any downsides to it. And there may be a few things that needs to be understood, and those are the things that the building owners and operators need to understand. That okay, if you put the system in place, this is how you're going to maintain it from there. It's no different than you put a pretty pink paint on a wall, and how do you maintain it, and how do you ensure that that same paint is maintained to its full? It's the same way, or any other thing that needs to be maintained for a long term life.
Right. Listen, and now my favorite question, and this topic has been through my episodes of
Yep.
ITS Laboratory Vlog, and it's about Auckland City Mission Project, and I know you are, working as a fire engineer on that
Yep.
project. So, and you guys were considering intumescent paint as an encapsulation at a certain stage of your work on this project, but then you opted for the plasterboard as a way to encapsulate mass timber CLT. So what was that solution based on? Why not intumescent, and why yes plasterboard?
I think the first thing at that point in time, I think the intermission solution was still being tested, and there wasn't much information available how things. We did have the discussion with Shane, and he was looking at the options of doing it. Secondly, there was already plasterboard linings to be provided for acoustic reasons, not for fire, but for acoustic requirements. So a lot of the walls would be lined with plasterboard anyways. So for us was to find a solution to use the existing systems that has been already proposed in the design, and then achieve the fire outcome that we wanted. Overall, it kind of made it more stringent requirement, because a fire lining is more stringent than just an acoustic requirement. But we were trying to use as much as possible the existing plasterboard that was fit into the design already, rather than get a new system and kind of change the whole design around it, because the plasterboard linings and stuff were kind of designed, and the details around door frames and other stuff were all already detailed up. So if you went for a different system, we would have done a lot of changes at the late stage of the design. All the design changes kind of happened when we were just going for building consent. It didn't happen in the design stage, which might have been more advantageous, I guess. But look, it was again a learning curve for us. CLT buildings and using a mass timber construction is still a lot of design work is still happening in it, of how we should be actually designing mass timber buildings, the risks associated with it, and how do we protect timber from continuously burning, because ultimately you keep adding fuel into the system. So yep. So I guess at that point in time we didn't use the intermission. We did have a lot of discussion on it. We had a lot of discussions with the clients in terms of what might be the easiest solution. I mean, adding plasterboard into the system adds weight. So we were looking at what are the solutions without adding the weight. So yeah, look, there was the consideration done, but at that point in time, we didn't really have enough evidence, or plus it didn't really meet the cost benefit of swapping for something to the other. So I guess in the future we might look at a different solution, but again, it'll come out with our discussions further with tech coatings when we have them going forward.
No cost optimization, but what about time? If, for example, if you guys had gone ahead with intumescent, if it would have diminished to reduce the timing of the project?
Yeah, probably might have, but one of the challenges at the point in time, I think the contract was building is not complete. So even applying intermittent coating might have been challenging. One of the things that the contractor was trying to do was try and line it up so that they could start installing services and stuff. Ultimately, they had to wrap the whole building, and because of the rain and stuff to protect it. So yeah, it was. I think at that point in time there were too many things that might have been happening at that point in time, and it was decided that we'll probably go with the solution that was already there on the table with using plasterboard
Right.
encapsulation. Yeah.
Thank you, Deep. Thank you so much for
That's
all
right.
of your clarifications and explanations, and thank you for joining today and being with us. And I hope we will repeat it once again in the future. Thanks.
No problem.
Bye.
Thanks for the opportunity. See ya. Take care. Bye-bye.
Bye.